Hello everyone, today I will explain how to get the formula of derivative of a function. Suppose fx be a real valued function that is defined on open interval ab. Real valued function means a function that takes real values only. Suppose we want to find the derivative of function at a point x naught that belongs to open interval ab. Suppose this is the graph of the function fx. And x naught is the point where we want to find the derivative of the function. Derivative means slope, and for slope we need 2 points. So we take another point x naught plus h, which is very close to x naught and slightly ahead to x naught. Now we have 2 points p and q on the graph, and this point p is corresponding to x naught. This point q is corresponding to x naught plus h. Now join the points P and Q. The straight line joining P and Q is called secant line, PQ. Okay. And the slope of this secant line will be this vertical change divided by horizontal change. Vertical change means change in function values. Horizontal change means change in x values. So simply the slope of this secant line is rise over run. Now let the point Q moves close to P. Okay. As Q goes close and close to P, it means H tending to 0. As Q tending to P means H tending to 0, the secant line approaches to the tangent line at P. Okay, this secant line PQ, green one, approaches to the tangent line, this blue one, at P. Means as Q tending to P, or you can say H tending to 0, the slope of this secant line approaches to slope of tangent line. Okay, so as H tending to 0 or Q tending to P, slope of secant line, this one, approaches to the slope of tangent line as h tending to 0, and which is the derivative of function at x naught. Geometrically, slope of the tangent line at P is the derivative of function at x naught. Now we can also approach point P from the left side, means take a nearby point x naught minus h, which is behind P. Means we consider Q behind P, and Q is corresponding to x naught minus h. In this case, the slope of the secant line PQ will be vertical change, means change in function values. This is f of x naught minus f of x naught minus h divided by horizontal change, which is again h. So this is the slope of secant line PQ. As Q approaches to P, as Q approaches to P, this secant line PQ approaches this tangent line at P, and slope of secant line approaches to slope of the tangent line as h tending to 0, which is the first derivative of function at x naught, and defined as limit h tending to 0, slope of secant line.